Okay, so in this reaction again you have to give the product. Okay, so let us see what you will do is, so first reaction is cold dilute KMnO4. Did you remember what kind of reagent this is? So this is used for hydroxylation. So in this case I have to add 2 OH group. So A will be, and now this adds in a syn way. Are you getting? So this is a syn addition of 2 OH. So the compound A will be, you have to add 2 OH group in a syn fashion. So let us say CH3 is upside, and then you have to add 2 OH, and that will be bottom side. Are you getting? So addition of OH is in a syn way. So you have 2 OH, and this is syn addition. Are you getting? Now let us see the second reaction, HiO4, and this gives B. What HiO4 does, so if you have a compound that is 1,2-diol, so this is 1 and this is 2. So if you have a 1,2-diol, the product after reaction with HiO4 is, what I have to do is I have to break this bond. CH3, CH3, OH, OH. I have to break this bond. Are you getting? And in the case of breaking, what I have to do is I have to add OH, OH both sides. So if I add both sides OH, and this is a way to write down the product. So let us forget about stereochemistry. So put OH here, and I have to put OH here also. Same thing on this carbon, I have to put one OH, and one OH was initially and one CH3 was initially also there. And now what I have to do next is I have to lose one molecule of H2. So from, if I lose one molecule of H2 here and one molecule of H2 here, so what I will have? I will have something like this, double bond O, CH3. Here also the same thing, double bond O and CH3. So this is the final product you will have. So this is your B. The next is, if this compound is treated with OH minus, and that is nothing but aldol condensation. So what will happen in this case? Now we have two options. I can make a carbon ion here. If I make a carbon ion here and attack, I will have a 4-membered ring. Another option, if I make a carbon ion here and attack here, I will have 1, 2, 3, 4, 5, 6-membered ring. So there is this possibility, is a better possibility, because that gives me a 6-membered ring. So let us make carbon ion and then attack CH3, and then you have double bond O, CH2 minus. So this carbon will attack here and this opens up. So now you have 1, 2, 3, 4, 5, 6-membered ring. So you have a 6-membered ring. Carbon number 1, let us say this is 1, 2, 3, 4, 5, 6. Are you getting? Carbon number 2 contains double bond O, so here I have double bond O. Carbon number 6 will contain OH group, O minus, and finally it will take H plus from water, so OH, and this is the CH3. So you will have finally this. So a 6-membered ring. This contains OH, CH3, and this carbon contains double bond O. So this is alpha beta. So this is a beta hydroxy ketone. So final product is beta hydroxy ketone. So in this reaction heating is not given. So let us write the final product as addition product, that is aldol addition product. If a small heating will be given in the question, in that case I have to write dehydration product or condensation product. In this question heating is not given, so let us assume the final product is aldol addition product. Are you getting? Let us discuss the next problem. So this is a quite good problem. So what the concept that is involved, that is one concept we have used, that the cold dilute KMnO4 does hydroxylation of alkene. Second is, if I have 1,2-diol, 1,2-diol can be cleaved using HiO4, and writing the product will be simply I have to break a single bond and put OH, and the next step you lose H2O molecule. Now the third reaction we have OH minus, and if you have alpha hydrogen that is present, then it will go to aldol condensation reaction. So this compound contains alpha carbon, so it will go through the aldol condensation reaction. Now heating is not given, so I will finally write aldol addition product. Let us discuss the next question.